We've seen Batman's Batmobile drive on its own. In iRobot, starred by Will Smith in 2004, cars were fully self-driving, with manual driving only as an option, and in the 2000 TV series Knight Rider, KITT is a fully sentient and autonomous car. Autonomous mobility and self-driving cars have been seen as a thing of the far future. But is it really? Watch until the end of this video to see just how close or far we are from achieving and integrating autonomous mobility systems on the road and who are involved in realizing this. Autonomous mobility simply means mobility systems that require little to no human input and assistance. While the most popular examples for this are self-driving cars, autonomous mobility systems are also used in logistics like delivery trucks and drones, to autonomous carts used in factories and large industrial facilities. Before diving deeper into the pros and cons of autonomous mobility, it helps to understand the terminologies and the standards set by the SAE International, a standards developing organization for engineering and technology professionals that span across industries. Let's first explore the difference between autonomous versus automated. Automation connotes a process controlled or operated by a machine, while autonomous connotes acting alone, independent, and self-governing. Nuancing these terms is essential since autonomous systems make the operation of the devices automatic since they are operated by a machine with very little or no human intervention. Wood et al. 2012 wrote in their study, "Most of the vehicle concepts that we are currently aware of have a person in the driver's seat, utilize a communication connection to the cloud or other vehicles, and do not independently select either destinations or routes for reaching them." Thus, the term automated would be more accurately describe these vehicle concepts. Autonomous mobility employs a combination of sophisticated technology to perceive their surroundings and detect changes in their environment. Technologies like radar for object distance estimation, lidar, and sonar for detecting its environment in 360 degrees, GPS, odometry, and inertial measurement units all work together for hybrid navigation systems essential to automatic operations on the road. Several cars with varying degrees of autonomy have already been tested on the road or are in development. Google's self-driving car that they've developed with Waymo has been tested since 2009. Waymo has also already launched their self-driving taxis, Waymo One in Phoenix, Arizona in 2020, which showed promise with the pandemic restrictions in place. Tesla has been making strides and has launched their autopilot software on their cars, promising frequent updates. Nissan also launched the Seamless Autonomous Mobility or SAM that partners in vehicle AI with remote human support to aid driverless autonomous vehicles. With the help of NASA's Verb software that came on interplanetary robots they sent, SAM aims to gather road information into a cloud to build it on top of their vehicle AI and share it with other cars that are connected to SAM, allowing cars to communicate with each other. But this technology is not just for the road. US-based startup Canvas has used autonomous carts to deliver packages and goods across their factory floors and working spaces. Another US-based company, iRobot, developed the Roomba, a robotic vacuum cleaner for homes. Amazon's Prime Air, medical delivery company Zipline, and logistics company Maersk have taken to the sky by using drones to streamline their processes. The employment of autonomous systems seems promising. For one, it would reduce road accidents. Human error accounts for a whopping 94% of road accidents. The National Highway Traffic Safety Association estimates that autonomous cars could save more than 300,000 lives every year by simply removing human error. A car's 360-degree view of its surroundings can also make a car react faster to avoid a hazard compared to a human's 135-degree vision. Younger people who can't have a license yet, the elderly, people with disability, especially those who are hearing, vision, mobility, and cognitively impaired, can benefit from having more access to mobility with the advent of autonomous vehicles. For many industries like, of course, the vehicle, urban planning, and oil industries, the rise of AVs can become disruptive. While we are not sure about widespread integration, this will cause profound changes everywhere. We could see changing or adjusting roads and highways for more intelligent vehicles, and integrating more autonomous mass transportation systems. Ride-hailing and ride-sharing services could become much more popular than it is now, as it might become cheaper. We might be less dependent on oil because people are taking public commutes more and owning fewer cars, causing much less traffic congestion. Industrial compounds could also build or renovate their production floors to integrate autonomous cars. As to why society would change, we have yet to see. For sure, drastic adjustments on driver and passenger behavior will be seen, and as well as our overall behavior on being mobile. But to actually see these changes would require a lot of willingness to change as well. Several hurdles are still keeping fully autonomous systems to roll out. For one, there are varying degrees of acceptance by people if they want to be a passenger of a self-driving car. In AAA's recent annual survey, only 14% of drivers would trust riding a self-driving vehicle, and a staggering 86% said they are afraid or unsure about the idea. Several legal restrictions are also in place. In Washington, D.C., the district code states an autonomous vehicle may operate on a public roadway provided that the vehicle 1. Has a manual override feature that allows a driver to assume control of the autonomous vehicle at any time. 2. Has a driver seated in the control seat of the vehicle while in operation who is prepared to take control of the autonomous vehicle at any moment. And 3. Is capable of operating in compliance with the district's applicable traffic laws and motor vehicle laws and traffic control devices. Varying degrees of controlled testing and restricted operations are in place in other places of the world. In China, Tesla has been banned from entering government and military compounds because their autonomous driving systems might be used for espionage. This is also a valid concern since it is unsure how location and driving data are used and stored, especially if a third party is granted access to these data. Some countries like South Korea are still very skeptical and pushing for legislation because of the lack of universal standards. Because of the absence of legal frameworks and regulations, this also poses a problem for insurance companies, car manufacturers, and owners in determining who would be held liable and what policies to follow in the case of accidents. There is also growing scrutiny on hacking and loss of connection to AI and cloud systems, since it would be terrifying if someone gets to control the car you're in or if the car systems bug down on the road. While most road accidents account for human error, we have yet to see how much of this will affect the safety and welfare of passengers with the human factor removed. As it stands, there is a long way to go before we can see driverless cars on our streets, but it is promising. We have yet to conquer challenges that restrict us from seeing the true potential of autonomous mobility in our society. But until then, stay safe, keep your eyes on the road and your hands on the wheel. What do you think? Will more self-driving cars on the road be just the stuff of science fiction? Let us know what you think in the comment section below. We hope you enjoyed and learned something from this video. If you did, make sure you like this video and subscribe to our channel for more substantial and awesome videos like this one. Thanks for watching.